Welcome to PdMA Corporation, home of the MCEMax. I'd like to thank you for joining us as we continue along in our presentation series. Once again, we have the Vice President of Product Development, Mr. Noah Bethel.
Hello from sunny Tampa, Florida.
And I am Todd Gunderson, the Vice President of Sales and Marketing. And Noah, this was on our website back in early, well, I would say mid 2015, 16, and we just revamped our website, so we're refreshing this case study because it's classic, and we want to put it on our YouTube channel. So we're going back through this again, but I think there's a lot of value here that we can share with our audience out there with respect to how does the MCEMax test servo motors.
It does. It comes in more often lately with robotics taking over a lot of the manufacturing processes, so very popular.
And how can we highlight 6-channel inrush?
One of my favorite tests.
Yeah. So let's just get into this here. This actually this was done by one of our regional account managers. He was out performing a demonstration at a facility, and the robotic arm basically moves boxes in several directions, but the actual problem was moving in the left direction. And so we decided, well, let's just check our current and voltage and see what's happening, because we have what's called inrush startup, but we can also use it as process analysis tool.
Absolutely, and it's probably a very often overlooked process, the ability that the EMAX offers.
Yeah, and when we try to convey to customers is that, yes, it is an inrush startup test. It's designed to be used for the startup, but you can also just collect 60 seconds of current and voltage, and there's a tremendous amount of information that can be attained in that signal. So we come here, and here's our scenario. It trips off at 100%. We're going to bring both our comparison servo and the actual problem servo to 90% and see what kind of data we can collect. So we're going to bring in the MCEMax to help us out here, and we're going to look at the online technology at this moment, and you can see just a little bit of different. Here's the arm moving from the right to the left, from the right to the left, right, left, right, and we're capturing the current and the voltage on all six channels, but all 3 phases of current and voltage. And what is this telling you, Noah?
Well, it's interesting because it is a lot of data, but when you actually break it down the way you have, where, hey, this is left movement, this is right movement, it starts to really sort of take life. And one of the things that I remember early jumping on to is, hey, look at this, the current, I don't know what you call it, signature, as it's moving to the right, it seems to be a lot less variable than the signature that was moving to the left. So that kind of cyclic loading makes you have to question. In fact, we start to lean a little bit towards a machine train anomaly, in that what in the load could be creating a different left load versus a right load.
Yeah, is there maybe mechanical binding? Because you don't necessarily have it, honed in yet to what this problem is. So we're going to take some more tests, or we're going to look at different data points to see if we can get a better idea. Is it mechanical? Is it electrical? So we're looking at the peak voltage and current levels. What are they at? So if I move on here, I can look at what when we collected the right movement and the left movement. Here our voltage and current is at 374 volts and 55 amps roughly.
Yeah, almost 60 amps for an interesting voltage value. I remember thinking at the time that it's kind of a rare voltage to see coming out of a normally, like, say, a 460 to 600 volt supply. You're going to go through the drive. You do expect it to change a little bit, but at 90%, it's a very interesting number.
Yeah, so we're going to pay attention to this. Now remember, this is your suspect servo raw data showing 350, 340, 370 volts versus 55 full load amps. So let's see what the actual one that isn't giving us problem looks like. And if we pull this in again and we're looking at the left movement, right movement, this is actually for the right movement now, and you can tell the voltages are completely different and the current is much lower.
a significant increase in the voltage to the healthy motor. And when you think of the power equation, a higher voltage is going to result in a lower current for the same power demand. And in this situation, you can see we're down under 40 amps. This is a significant load difference for exactly the same demand of 90%.
You're talking almost a 30% decrease in current. What does that do to a motor if it's running 30% higher over time?
Well, once you approach full load and you're running that much higher, I mean, you've heard the thumb rule. For every 10 degrees higher than design, you're going to reduce the insulation life in half. So even if they're not exceeding design at this point, and they're going to trip the motor out, how long is that going to? It's way overburdening the motor.
Yeah, and it kind of now does this kind of drives us more into maybe electrical,
right?
Not
We're
mechanical.
Exactly. Originally, we were sort of leaning towards machine train. Now, when you start talking about voltage variations that are improperly being delivered, now we're going right back to the power supply and to the servo drive and looking at that.
Yeah, and we can see here it's 500 volts versus 350 volts. That's a huge difference.
Monster.
So now we can look at the actual comparison again between the two.
Right, you can see
Lower
how
voltage.
full the voltage signal is on the comparison servo, the healthy servo, versus the break-in voltage that's creating a much higher current demand on the suspect servo.
Now, we always like to go back and, what are some other things to think about when we're doing servo analysis, give you little tidbits of information out there. Can you explain some of these for us?
Yeah, one of the things that's interesting with servos is, and you and I kind of talked about this before, servos are very application specific. They're not sold into a common environment. So it's critical to get that baseline. You always hear us harp about get the baseline, and when you don't have a baseline, at least compare it to a like servo. Which one of these is not like the other kind of approach, right? And so that is absolutely critical to get the baseline or the comparison, and that's really what gave us the insight to help make a good decision on this troubleshooting.
Yeah, and some of the other things on here, let's not forget our 6 fault zone approach in analysis, right? You want to try and isolate, isolate to really eliminate areas that we don't have to spend any attention to. We really want to put all our focus on the problem area, and when you break things down into those 6 specific fault zones, you can start to really focus in, hone your skills in on the area. So in this case, for instance, if we did an MCE test and we had high resistance to ground, we would not look at insulation.
You're right. And one so often leads to the other and is a
Yes.
byproduct of another.
And then lastly, that 6 channel really kind of helped us to go into, also it helps in our demodulation where we can look at mechanical applications now.
Can't say enough about the fact that mechanical load variations and torque issues do affect the motor in a big way. And you can use the motor, like you said, as almost like a microscope into the machine train. And it's absolutely something you want to apply every opportunity you get is to look at that machine train through that demod test.
Well, as always, we appreciate your attendance in reviewing this. And if you happen to like this video, as we always say, go ahead and hit the like button. But if you dislike it, don't do anything. We don't really want to hear about that. But if you have any information you want to share with us, please feel free. You might get a jacket, a hat, a cup. We've got a lot of a buff now. Buff. You could get a buff. So please don't hesitate to give us a contact either through our website or through our phone number, and we'd be more than happy to entertain if you have a case study that you'd like to share with the group. Until then, you stay safe out there and you have a great day.